Webcast is now starting. All attendees are in listen-only mode.
Hi everyone, thank you for joining in for our webinar today, which is on how to master your claims processing with advanced analytics. My name is Sim Bajpai and I'm the Director of Business Operations at Innovizent. One of the prime offerings that Innovizent has is claims analytics. In fact, our solutions offering resulted in a 20% in surge in revenue within a business unit, strategized and implemented real-time fraud detection and analytics in the claims function for an insurance company. Our speaker for today is Mr. Souvik Das, with 18 years of experience in data management and analytics for financial services industries. Souvik is SVP and Practice Lead Analytics and Data Practice at Innovizent. He has strategized and led multiple data management analytics initiatives across industry practices. Before going to the webinar today, a little bit of housekeeping. If you have any questions, please drop in a message on the control panel of the GoToWebinar. We will bring them up at the end of the session, for which we have allocated 10 minutes. This call is being recorded and will be available on our channel and sent after the session to all the attendees. So without any further delay, I will pass on the session to our speaker and understand the potential of analytics for improving the claims business.
Thank you, Sim. Good morning and good afternoon to everyone based on where you are. This is Souvik, as Sim has very kindly mentioned. I manage the analytics practice within Innovizent. I have about 18 years of experience, all of them predominantly in data management areas. What I'll do today is we can move on to the agenda slide very quickly. We will structure our discussion this way. Sim, could you please move on to the next slide? Yeah, thank you. So we'll start off with Innovizent's corporate overview. We're going to keep it very short and sweet. Then we will talk about claims in the context of insurance industry, as in insurance industry would have different kind of function points, different components. But how big is claims? How significant is claims? We're going to talk about it in this particular section, and we're going to substantiate our points through different data points, and we'll talk about the sources of those data points too. Then we are going to talk about the challenges in claims processing. Today's traditional claims processing, what are the predominant challenges, what drives inefficiency, what drives surge in bottom line, we're going to talk about that. And then how claims analytics can address those challenges. Analytics would be one of the many things that would be needed to, in our opinion, as per industry's opinion, would be needed to change the problem areas. But we are going to focus on analytics and the business value that industry can derive from it. Then we are going to take a reference architecture. It's an indicative one. Obviously, it would change. It will be nuanced based on a particular client's requirements and landscape. But we're going to take one indicative reference architecture, and we're going to explain how a typical architecture would look like to facilitate claims analytics. Then we are going to touch upon very briefly claims performance management, one of the areas which claims analytics contributes to. Lastly, we're going to talk about Innovizent differentiators. What are those specific as well as generic differentiators offered by our company, specific being the ones that are very, very specific for claims, and generic are the generic company differentiators, and why we think we are one of the best, if not the best, in the industry. And lastly, a case study that we have done. We have done a few. We are going to talk about one of them. This is from one of the insurance companies from the Midwest, where we have done several things on claim. We're going to talk about claim fraud detection. We have done a few things as well. So once we go through this, we'd request you to hold your questions, and then we are going to take your questions after the session if you have any. Okay, if we can move on to slide 3. Very briefly, our company is a spin-off from another company which is in existence for 20 years. About 2 years back, we felt the need of being laser focused on data management. That's why we spun off this company. This company, all it does is data management. We don't do anything else. That's our objective. We want to stay invested, engaged completely on data management areas. Now, when we say data management, on the left-hand side of your screen, left and bottom side of the screen, you can see that these are our areas of offerings. So data quality, data governance, big data, data integration, MDM and RDM, which are master and reference data management, BI reporting, and data science and analytics, a practice that I lead. Data integration, amongst those things, it also covers data engineering. Now, we do have global presence. We have got presence in US as well as in offshore in India. We offer different kind of operating models, either all on-site or near-shore or on-site offshore. Different kind of models are available based on customers' comfortability and different other drivers. We have 100-odd consultants spread across the globe, 20% of which we consider as part of our core team, and then 70% of those core team members, they have PhDs from leading universities, and the other members are also either hugely experienced or come from leading universities in the US or elsewhere, or both. We are a services company. We're not a product company, but we do have different digital assets that we position as solution accelerators. We work very closely with industry leading product partners like SAP, IBM, then Hortonworks, and many other companies. We do have certification system processes for many of the software that we work on. We also develop solution accelerators in collaboration with some of these product partners. So with no further ado, we'll move on to the next slide and we'll talk about claims analytics. But any question on the company, we can take it on towards the later part of the discussion or offline. Now, let's first talk about some of the facts about insurance, and let's put claims as a discipline or subject area in the right context. Now, based on the data point available from S&P, Standard & Poor, and other sources, which is up until 2016, with 2017 data still being compiled, here are some of the interesting stats. You can read it out, but I'll put some more colors to it. First point is the US insurance industry's net premiums is worth about 1.1 trillion in 2016. If you see how the net premium has trended over the last 5 years, it has been more or less stable since 2012. Now, of that 1.1 trillion, premium recorded by life and health insurers, it accounts for about 53% of them, and the PNC or the property and casualty insurers would be around 47%. The second salient point is insurance carriers and related activities. They contribute about 2.7%, or in absolute figures, about $507 billion into US GDP, gross domestic product. And this is from the data obtained from US Bureau of Economic Affairs. Number three, the point they've got is it employs, at least in 2016, it employed about 2.6 million people in the US. And this is data obtained from Department of Labor. If you look at the data available from 2007 onwards, this figure has been very steady. It has not really dropped or surged. It has remained roughly at 2.5, 2.6 million range. This also includes a workforce in the insurance carriers as well as brokers and producers and other insurance agencies. So in short, through these 3 points, the point I was trying to prove is insurance obviously is one of the very steady, very significant industry across the world and specifically in US. Obviously, outside of the numbers, it carries equitable risk for various other companies. So it's kind of a fundamental structure within the economic framework of a country, if you like. Now let's look at the profit and loss data. So PNC industry, which is property and casualty, which is about 47% of the premiums written, roughly 523 billion in 2016, had to pay out about 318 billion in claims. In fact, the number has been anything between 270 to 320 billion dollars in each of the last 5 years. Uh, Hundreds of billions of dollars each year go to the claims against hurricanes, for instance, or damages caused by hurricanes in the US. Similarly, in life, health annuities, which earned a premium of roughly 600 billion in 2016, had to pay out about 270 billion in benefits. Again, the bottom line that we are trying to prove here is claims is the single biggest expense in insurance industry. Roughly between 70 to 80% of the premiums earned would flow through as expense or indemnity payments for claims in insurance industry. So the obvious thing that we can derive from here is that even marginal improvement in claims process can improve bottom line of the insurer significantly. It can contribute billions of hundreds of billions of dollars in absolute terms, in terms of its bottom line efficiencies. The other point here is that money aside, these data points aside, since claims is such a delicate moment of truth in a customer's journey with the insurer, oftentimes it can make one lifelong customer or a detractor based on the customer's experience during claims handling. So with that, and hopefully, after establishing the significance of claims and significance of insurance and significance of claims in insurance, I'll move on to the next slide. Okay, in this slide, we are going to talk about some of the challenges that we see in the insurance industry. I'll go through these challenges written on the slide very quickly, then I'll talk about in a bit more detail as to what we mean by this. So first is a huge amount of unstructured data that is needed for claims processing. Now you have to combine with the second point, which is archaic technology platform that most of the insurers today use. They are not capable enough to handle that amount of unstructured data or derive insight out of it. Therefore, there is a huge amount of manual intervention that is needed to get insight out of that unstructured data. Now, what kind of unstructured data we are talking about? We are talking about different kind of data, for instance, medical reports, doctors prescribes, different notes from which the investigation agencies or units, they derive the merit of a claim, as well as different amount of structured data. But it requires tremendous amount of data, mishmashing of that, and then derive the outcome from that, which the existing technology in most of the cases would not be able to handle, and therefore the need for manual intervention. There is an age-old support ideology also. We'll take you through how typically a claims process works in case you don't know that at great length. And you'd understand that the way the adjusters are incentivized today, it's not really merit-based, it's not really priority-based. It is more of volume-centric, and that ideology really doesn't get us anywhere. The prioritization really doesn't happen in a way it should be. The other thing is, once the claim is settled, the performance measurement is really poor, which means that how much priority claims have been processed in what amount of time, what was the quality of the claim settlement, if you like, whether the customer was a loyal customer or a priority customer or a customer on the verge of delinquency, and how did we treat those customers. Those reports and dashboards are not really there today. Most of it's about how much an adjuster has resolved or settled or processed in a given quantum of time, and that's about it. The KPIs, that's why we say, are misaligned. It's not really aligned with the business objective of making claim processing efficient or improving the bottom line, for instance. And it's heavily manual oriented. So today, um, most of it would be adjusters going through different set of records, eyeballing them, uh, going through the policy, and then eventually making a decision. Since it is very automated, many claims would have to be would undergo delay for weeks, sometimes months. Sometimes there'll be error in the judgment or even error in the notes and the descriptions that adjusters or whichever other party is dealing with the claim within the insurance company. So all of these are causes, and we'll take a bigger stab at it in a moment. But the effect is it being inefficient and reactive. There is no proactive way of measuring where the claim for which customers the claim could be settled, or maybe fraudulent for that matter, where we didn't set the right premium. The feedback loop into the pricing or the actuarial, that hardly happens in today's world. All of that leads claims being one of the expensive functions, and it reduces companies' financial performance, and it also leads to poor customer experience. So, what do we need? We need innovation, we need investment, we need policy changes, and we do need cultural shift. With that said, I'll just elaborate this point, this particular slide a bit more, so that we understand at length what we are facing and why there's a need for change here. So, according to a recent State Street report, only just 39% of the payers say that they are effective in collecting and aggregating data, turning it into actionable insights. Other 61%, they still need to make the change. And this is a report only from State Street. If we aggregate it, I think it's a reflection of what insurers think across the board. Now, we talked about the expanse of unstructured data. What we meant by that was healthcare industry or insurance industry. It's full of clinical data, claim data, patient data, hospital system data. Data is scattered and stored in multiple disparate formats. Sometimes structured, sometimes unstructured, but even structured would be in different formats in different legacy systems. These are often underlooked or underutilized. As a result, the challenge is how to find the right data or how to position or map the data to actionable KPIs. The process of analyzing this data collectively is hindered as data scientists have not embraced a means to aggregate the disparate data sets. So, in fact, the concept of using data scientists in the claims processing is very, very new. Then comes the current technology environment. So insurance claim process, it consists of multiple decade-old platforms, applications, and databases. These are not really the ones which are suited to get insight out of unstructured data at a huge volume. The vast divide in technology landscape is not also allowing systems to handshake. Hence, issues such as security or point-to-point integration, these would add to the delay and confusion. And confusing supporting ideologies. So claims management is a complex process for the entire organization, especially as more payers are transitioning to data-driven, value-based core models. So submitting a claim involves more than just pushing a button. Claim processing requires extensive data to be processed before any claim is approved, and we'll talk in a bit in the next slide as to how that process works. But manual processing of claim may involve significant delays. I mean, it can be days, months. It is human error prone. The other thing is the way the support staff is incentivized that is not aligned also. The point that I have not touched upon while going through the slide was the progression of policy. Now, adoption of technological changes are still in process, and the changes in policy are making system unhealthier and overstressed. What do I mean by that is the modifications in US Patient Protection and Affordable Care Act, which is PPACA, are expected to have a profound impact on health insurance business. That is one case in point, because the act requires health plans to accept all applicants, regardless of any pre-existing medical condition. So PPACA further restricts rating approach alternatives, leaving payers with limited tools such as deductibles, co-payments, to apply in risk assessment, pricing, and underwriting. So payers are expected to leverage both disease and wellness management to incent customers to maintain their health and network provider management. So in essence, the um, the analysis that would need to be carried out by the insurance companies, or for that matter, medical companies, it can be healthcare too, is very, very limited because of this policy inclusion. So just to summarize, before we move on to the next slide, traditional claim management processes is inefficient, manual, error prone, and it eventually leads to this being expensive and something that oftentimes results into bad customer experience and drives loyal customers away. So with that, we will move on to the next slide. So this slide is to remind ourselves, what are we solving? What value are we trying to get from analytics? We have discussed at length as to what is the problem area within claims. Now, through analytics and advanced technological improvements, what we are trying to bring to the claims processing is predictability, efficiency, and automation. When we go through maturity progression for modeling, it is often said that you go through the one that is described on the slide from left to right. Not necessarily you build them in parallel, but it is oftentimes said that when you implement reporting, then descriptive, then predictive, then prescriptive models, the value that you get, it goes through a progression. We have jotted down some of the key use cases that can benefit from each of these modeling techniques. But before we go there, we will talk about how the claims processing essentially works. It is a complex process. At a high level, once a loss is reported, a claims is assigned to an adjuster. Based on the complexity and severity, there will be many classes of adjusters. So the claims would be routed to the right adjuster, or it's supposed to be that way. The process that entails to analyze the claim is called claim strategy. Now, this determines the merit of the claim and eventually the payout, but it's a long drawn process. The other point to mention here is that as a claim develops, the reserve for that claim or to settle that claim usually has to be revisited multiple times. A claim also needs to be considered for subrogation and thereby maximum recovery. And lastly, litigation costs. If this claim is not settled correctly or on time, it can go to litigation. And it is one of the major sub-expenses within claims. In today, the estimation is that only 3% of the policies undergo litigation, but those 3%, for those 3% of the claims, the insurers pay about 12 to 15% of their premiums to settle those lawsuits. Now, what it means is analytics, how exactly it would help. So a standard claim processing can be aided by analytics in different ways. For instance, claims analysis, where the outcome of analytics enables better and more accurate decision making throughout multiple decision points. And we will go through some of the use cases written in the slide in a bit. But those Most of them would fall under the claims analysis area. Then there is a reporting and dashboard, which predominantly is on the left-hand side, the ones that you see. It would help insurers and its stakeholders in various ways, such as governing claims reserves, expecting loyal customer claim handling, and reduce settlement. There are different operational metrics that we can also do. Essentially, it will aid A, better tracking, a more detailed tracking, um, B, highlight wherever we need more attention, more priority. And then lastly, modeling. Simple um, modeling techniques are in some cases complex. Advanced modeling techniques that can help claims processing a great deal. For instance, fraud detection. When claim comes in, there are different methods that we can apply to detect fraud. We can either do it at a bit of a latency, or we can even do it in real time. Our company had the opportunity to implement claims fraud analytics in real time for one of the insurers. Now, other than that, we can reduce litigation expenses by proactively predicting which claims can undergo litigation and prescribing what kind of um, um, steps that we need to carry out to avoid that. As a whole, it helps create better customer loyalty, better and more efficient culture within the company at large by increasing customer experience, by injecting a good amount of efficiency and accurate predictability within the system. Now, when a claim comes in through natural language processing, a fraudulent claim can be detected. We are also seeing the pattern wherein blockchain technology is extensively used for fraudulent claim detection. Then, of the claims that are legit, analytics can help segment the claims based on materiality and complexity and create dynamic scoring. Dynamic scoring, if you go to any of the healthcare shops or insurance companies which are implementing analytics, they would say that dynamic scoring is right at the heart of their claims analytics process. This is kind of fundamental, and it then gets fed to the downstream processes, which is essentially claims BPM kind of application, business process engine, and then various decision points. This dynamic scoring that is obtained from the analytics that is done before um, helps or takes part in. This dynamic scoring helps claims adjusters in different ways. It helps them focus on the right claims as opposed to the easiest claims that happens quite often. As I said before, it's because of the way the incentives are designed today. Um, Now, through NLP and text mining, various system parameters could also be autofilled that we needed for claims processing and that obviously drive efficiency. What it simply means that there will be different document which are hard documents, not really soft copies. There are ways you can take the relevant information, put it in a softer forms in the soft copy fashion, and then you can store them in your document repository, which would be needed for your claims processing. Now, it used to be um, a manual process, but nowadays with the advent of NLP and text mining, those things could be done automatically for most part. One of the things that analytics has been doing outside the context of claims is they have been segmenting. Analytics has been used for some time now for segmenting customers and analyze customer behavior, predict how much profitable the customer would be, how much loyal the customer would be, and so on and so forth. What we have seen traditionally is that customer segmentation, which is usually used by the sales and marketing teams and even in some cases servicing teams, it's hugely detached from the claims area. Claims adjusters, in our opinion, can get a lot of value from the segmentation work or different other analytics work that sales and marketing team usually does. Now, analytics can also help subrogation process that are more prone to go to litigation. Also, any claim which is really more prone to go to litigation and help insurer take proactive action. Lastly, dashboard and visualization. It helps stakeholders take an aggregated view at times. It helps in different other ways. Um, and what we'll do is we'll just you know end this slide with a few key use cases as you mentioned before. So reporting, there are different kind of dashboard reports that you can create out of analytics. These dashboard reports in an ideal world would be embedded within the same platform that you're using and will be given access to various stakeholders at various levels. Some of the dashboard reports would be for alert purposes. For instance, loss alert for first notification or proactive notification of a loss where either at a claim level or at a business unit level. Then dashboard for adjuster performance. This is hugely missing today. You can define KPIs and you can measure them, and you can aggregate different performance parameters and then see how an adjuster is performing. Operational matrices which are far down below at claims progress, for instance, closure ratio, loss ratio, payout ratio, you can monitor them very efficiently throughout the journey of a claim. Now, descriptive use cases on the right-hand side of reporting would include claim segmentation. As I said, oftentimes claims are segmented. I mean, in traditional cases, claim is not segmented. Every claim kind of is regarded as the same kind, and they're treated the same until late in the process. But what we can do through analytics is we can segment the claim based on various parameters, but fundamental principle being segmented based on materiality and complexity. And then you route it through different channels. Similarly, customer segmentation, as I said, it's not really a claims area; it's predominantly a sales and marketing area. But sales can claims can take advantage of it. We can also do litigation management, mediation management through descriptive analytics. Predictive would be typically dynamic scoring, the subrogation model, the fraud detection, and severity and materiality models. The prescriptive would be claim severity projections, claim reserve projections, outlier claim modeling, and pricing recommendations. One of the things to mention here is that prescriptive is kind of nirvana in maturity progression. It's a kind of the end state wherein the system itself prescribes what would be the next step, along with predicting what could be the forthcoming outcome, if you like. And it helps in different ways as your models become really efficient and accurate. You can take proactive measure in reserving capital to safeguard against the claim that is coming your way. Pricing recommendation is another very useful modeling technique that you can do by combining the outcome of the analytics that you are doing on claims and feeding it to actuarial, where the premium prices are decided. So with that, we will move on to the next slide, please. So this is a reference architecture. We've talked about what is the problem and what kind of solution, what kind of value analytics can add. This is a slide on how. And obviously the how part involves the physical implementation of claims analytics. Now, what we have here is in this slide is a reference architecture. If you focus on the diagram on the right, the top side is where the data is coming in from. Essentially, even before we go there, this describes a platform on which claims analytics could be implemented. What do we not have in this particular picture, and I perhaps will just describe, is how after doing this, a claim management system should look like. Now, this particular platform is no different from any data lake, big data lake platform that you'd see, wherein we build Customer 360. We are not prescribing that we build something different from claim. What we are saying is your standard customer 360 that you build as an enterprise solution for customer journey, that solution should be sufficient for claims analytics too, provided you capture the right data. So we capture all the data that we can for a customer and its policies, products, medical records, social data, third-party data, maybe HR if you're talking about health insurance. And we on the top half of it, that's the data acquisition layer. That's where you see the word all data. And that's where my previous point of the expansion of the data, the variety, the volume of the data that comes in that is involved in claims. Once the data is acquired, obviously, how do you acquire data? There can be different APIs, different modalities in which you can bring the data into the center part of the picture, which is the data management layer. It can be batch, it can be real time, near real time, web services, traditional APIs. It can be streamed through Kafka. It can be literally um, anything based on your need as well as system compatibility. Once it is in this um, region, which is marked in black, or in other words, we have said as data management, most of the organization, they are going for big data technologies to build out this central piece. What would this central piece contain? This central piece typically would be divided into 3 to 4 layers based on which company we're going to. One layer would have operational data, then the other layer would have landing and exploration data, archive data, and then we have a the data that is there is harmonized, standardized data quality checks and business rules are applied, and then it gets routed into 2 areas. One is EDW and data mart, which is enterprise data warehouse, and the other one is analytics ready data. Oftentimes you've seen that the physical implementation of the last two is the same, so you don't have two different areas for EDW and analytics. So you have one single physical place to contain both kind of data in many cases. There will be real-time data that would also flow in and would go through the same channel. Now, once your analytics data is prepared, it flows through different layers. You then carry out, just like any other data science program, if you run, you'll have to have a sandbox wherein you can do discovery and exploration. So that is one area that is obviously needed. Now, once you finalize what is your end objective, what methods that you're going to use, what kind of value imputation that you need to carry out, all of that is settled and the model is roughly operationalized, then we can move on to different dedicated areas based on which kind of model have you developed. For instance, if you have done a predictive, or if you have done a cognitive, or um, simply have created some visualization, reporting and dashboard, or you've created a prescriptive decision management kind of a model. You can have different areas for them. All what you can do is you can build a model factory kind of a framework wherein you can keep all the models and you can create a scoring repository to keep all the scores against a particular data set. This is kind of a layer that sits on top of the data layer and processes. This can be built in R, it can be built in Python, and so on and so forth. It can use Spark, or it may not, depends on what kind of data set we are talking about. The outcome of this would then be fed into different systems. So customer experience is one system which would then take into account the servicing of the claim, as well as ensuring that customer experience module takes care of or takes into account the outcome of the claim. Financial performance, because it drives efficiency, so it's supposed to contribute to it. Risk and fraud, because claims analytics inherently will do fraud detection, and that should be fed into the centralized risk and fraud or governance and compliance security kind of a function within the company. It obviously would have to go to operations to track the efficiency of the application. So this is at a very high level how the reference architecture would look like. Now, how the claims management processing platform would look like as a result of this claims analytics would be simply a BPM kind of a tool, which is nothing but a business process engine, a workflow-based tool wherein adjusters take one step after the other. The only difference is that tool now would need to be integrated with the outcome of this analytics, and then the intelligence and insights gathered from it should be plugged into each of the steps as appropriate. There may be need to create new reports, which should then also be integrated within that platform. But what we prescribe and what we have seen being used very efficiently is that one integrated platform for claims management. It really really helps. It drives efficiency in various ways. It essentially means that the adjuster doesn't have to move from one place to another and go through different systems just to get value out of analytics. With that, I'd like to move on to the next slide, please. Yeah, this is a performance management. We will just very quickly touch upon this because we will talk about this in the case study also in some fashion. I will just substantiate that how analytics has helped through this prior state and end state as left and right. The prior process before implementing the analytics would be something like it's fully manual, individual claim based. Committed SIU is a very, very decentralized kind of SIU. Staff trained in specific areas. And then adjusters retain control of decision making with inputs from SIU. Little data on the performance management. This point I kept repeating. And then because the workflow is not really automated many times, referrals to SIU at very late in the game, this causes further delays. After implementing analytics, what we seek to gain would be use of predictive and prescriptive. Predictive to identify potentially fraudulent claims proactively, really. And that would be not based on someone's gut feel or eyeballing the records, but through automated processes based on the insights gathered from these models that we have developed based on structured and unstructured data. Then we capture trends, how exactly the company is doing in terms of claim settlement, how the trend is going across the country, and then take some strategic decisions based on the trends that we derive. SIU may be in-source, may be outsourced, but we can derive some level of efficiency there. And then better collaboration between SIU and adjuster. I'll keep it at that, and we'll touch upon this once again during our case study. Let's go to the next slide, which is slide 9. So, why Innovisant? What are our core offerings and differentiators? The ones that you have here, it's more or less generic differentiators that Innovisant would bring to the table for any project, not only related claims. So we have the best of people. We have our proprietary methodology that we use, which drives efficiency, reduces cost, and our technological know-how and the partnership and the solution accelerators that we bring to the table. We spoke about most of it. What we have not spoken about before, and then also we have not touched upon in this slide, but I'll speak to it, is that our experience in claims analytics in particular. We have done at least 3 live implementation across insurance and healthcare. And in all three implementations, it is not implementing a module, but we have implemented end-to-end, getting the data, doing the analytics, obviously before that, scrubbing the data, doing fraud analytics before that, then integrating that with the existing claim management systems. In fact, in one of the cases, we have created a claim management system from the ground. Also, in another case, we have been able to stand up a call center to support the claims too. Now, claim management would also vary. It would be nuanced based on whether you are talking to healthcare industry or you're talking to insurance industry. They are conjoined, but the nature of the dealings would be different. We have the experience of implementing claims in both the places, in both healthcare and insurance, and that kind of extends our know-how in this particular place. Plus, we have got functional experts who we have recruited from the claims industry, as well as obviously data scientists who come with good amount of experience that set us apart. Lastly, we'd go to the case study. If we can move on to slide 10. There's a bit of lag in the system. Sorry about that. So,
Yes, yeah.
Yeah, case study is on fraud analytics, but really we have done end-to-end claim analytics in this particular um, client. As I said, it's an insurance company based out of the Midwest. Its challenges were data quality, access and integration of unstructured data. It's a very simple way of putting the fact that the quality of the data that we got, it was so heterogeneous. We were having hard time even understanding um, what to take, what not to take, how many variables should be needed, and all of that. More importantly, we didn't know which one would be fraud, and in many cases, before the analytics implementation, which we actually proactively pitched. This was not a business use case given by the business. We proactively pitched and said that this is something that the industry is doing, and we manufactured not a manufactured as a negative connotation, but we built a business use case, got the funding, and then we eventually implemented it. But we didn't have any mechanism to know proactively what would be a fraudulent claim. And by the time a fraud is detected, it may be very late in the game anyway. Access and integration was all batch. It was all manual heavy. And unstructured data, obviously, as I said, many of the data would come from documents or various other sources, which would be very, very unstructured in nature. So we developed a capability. We built it on Python, and it is built to create and notify the fraud incidents. The solution obviously was hugely appreciated. We were initially building a batch solution, then we moved on and we built a real time. We re-architected part of the solution while doing that. This resulted in faster claim settlement because by the time the claims were reaching the business process down below, they were already knowing one thing, that this would not be a fraudulent claim because fraud was checked right at the gate. We implemented both rule and non-rule based methods to intercept fraudsters. And then what I mentioned before, some of the highlights would be that we integrated the solution with the claim management platform. We integrated in such a way that the actors on the claim, the adjusters and others, they don't need to shift from one place to another to find out what value this analytics is bringing to the table. This became a very repetitive factory model eventually, and we built it in a way that we hardly would need to touch these models ever again unless new set of business units are created and this new kind of policies come into place. We did that for AD&D, and now we are extending the model for life and health going forward. So This was one of our flagship case studies. If we want to know more, we would not want to know anything at the code level, we'd happy to take you through that. But this happens to be one of the many success stories we have in this space. With that, um, I would end my presentation, and if there are any questions, I'd be happy to take them. Sim.
Thank you, Souvik. Yes, I do have questions with me. The first question that I have is what kind of data is required for claims analytics?
Okay. I think we mentioned that already somewhere, in the at the start of it, but I'll repeat that anyway. So claims analytics, first and foremost, you'd need customer data. So previously, customer data would just mean it's some of the basic information of the customer. Today's world, the customer data would be augmented by its social extended lifestyle, behavior patterns, etc., which we may or may not get from internal sources, hence we augment that through outside sources. Um, then we would need policy data, which would obviously referenced with customers or associated with customers. So that usually we get from the policy admin systems. And then we need different other data sets. It can be medical records, it can be the claim description, evidences of the claims, which can be simple documents or can be information and even sometimes picture from the in case of auto, for instance, if there is an accident that has taken place, the picture from the place of the event. All of that taken together, a claimant would, a claim adjuster would make a decision during triaging. And that's what makes it really so complicated, because it is not only the volume of the data, but also the variety. It can be simple text, it can be structured, it can be unstructured, it may not be text at all, it can be something else like picture also, which makes it so difficult to deal with up until now. Obviously, now we have these techniques through which we can automate large part of the process.
All right. The second question that I have is what infrastructure is required to implement claims analytics?
Yeah, sure. I'd not say that if a company is already implementing analytics within its business or within its landscape, sorry, it's not, claim analytics would not require much of additional infrastructure per se. What exactly do we need in claims analytics? We need a data layer to hold all the data sets that I've just talked about in a centralized fashion, so that the claims analytics then don't need to go and find the relevant data sets from 200 different places. That persistent data area usually is the big database data lake that companies these days would anyway create. They are in different um, point in time in their maturity level, but that is the place on which analytics run. Now, what we need to assess is if an insurance company or healthcare company is building their customer 360, whether it is claims ready or not. Just having customer and some of its details which will aid to sales and marketing. Many of the cases I've seen sales and marketing being this pivotal use case for which this customer 360 is built. We need to ensure that claims gets into the picture when it comes to that customer 360 building on big data platform. That big data platform can be anything. It can be the platform of choice and it will vary from one company to another. You'd need integration to bring on-premise traditional data sets into big data platform. Now, big data can reside on-prem, can reside on cloud. That would be dependent on your cloud strategy. But there would need to we need to have a certain level of integration done to bring the data from traditional sources into this big data platform. And there are different kind of methods available for that. It can be ETL, which is big data ready. It can be Kafka streaming. It can be web services, microservices, APIs. There can be different ways, or MQ, for instance, message queuing, through which you can bring data into this platform. Now, once the data is there, um, in any data lake, you'd see roughly 3 layers to it. I said 3 to 4 layers, but there'll be a place where the data lands in its raw format. Then, simply put, there will be a layer where we store harmonized data sets, uh, and we model that data warehouse around it. Within that, the same space, or maybe logically a different space, what we also do is we create a space from where analytics can draw data. These are not separate technologies per se. This can be your Hive tables, or this can be any other persistent layer that is available with big data technologies. Now, on top of that, you have to build the core function, which is the modeling techniques. And prior to that, you have to scrub the data, analyze the data, scrub the data. So those scrubbing the data can take traditional methods like using Informatica data quality or IBM's quality stage and so on and so forth. For modeling part, one can use R, Python, or SAS for that matter, or any other modeling tool that is in the market. So that will take care of your prescriptive, descriptive, as well as predictive modeling. The reporting, which is the fourth one, first one in the progression model, that is usually done through visualization tools like Tableau or Click. What we also need to do is that outcome of the analytical models would need to be stored for future reference, for persistence, for consistency, and so on and so forth, for which we create scoring repositories. Now, this scoring repository can be any other table on big data. And then you need to again use the same integration channels that I spoke about to federate the data across different consuming applications. So use the ESBs, or micro web services registered on ESBs, or batch process, or streaming APIs to federate the data in different consuming applications. So that's the infrastructure need of it. You can go through the slide where we had how, which is I think slide 4 or 5, and you can literally map each of the layers with a set of technologies that are available in a respective layer. Sim.
All right. We're running out of time, but I will take up this question, which is how Innovision adds value to the business.
Yeah, sure. I mean, one of the things that we have seen, and I brought up that particular case study for a reason, is that analytics in general, not only limited to claims processing, but in general, it many times um, fails to connect with the business community. There is a cultural aspect of it. There is also a practical aspect of it. The business oftentimes says that it is running for decades without the intervention of analytics. I mean, they many times they see it as an intervention as opposed to value add. They are obviously their KRAs are goal oriented, profit and loss oriented, so they need to bring more business. They need to ensure that the business, the industry is growing, or the company is growing. That's their KRA, that's their KPI. Oftentimes, we have seen that analytics function, the data scientists, they live within their own cocoon, and then they talk in a language that the business fails to understand. This is a fundamental problem that we have noticed in many places. There is an advent of this particular role called decision scientists, which is really coming up to bridge that gap. These decision scientists would come from business. They would understand the technology aspects of it, the data science aspect of it, and then will be able to effectively communicate this back to the business stakeholders. The first and foremost, because your question is what kind of business value Innovision can add, is that we have such decision scientists already embedded within our team. We felt the need of it about 1 year, 7 months back, through some battle scars, really. That is number one. Number two, general skill wise, we have resources who are world class in as data scientists or as functional experts. Um, Now, we also have claims experience. Experience is next to nothing, right? So we have experience in implementing three very complex cases, three very different cases. But in all three cases, we have implemented end to end, so we know what kind of nuances we can face when it comes to claims analytics. It's a big differentiator for us. We are also in the process of building digital assets from our learnings without compromising on confidentiality. And what we then do once it is built, which we expect to be built within Q2, is that we want to build that, we want to get that in front of the customer as solution accelerator. We don't want to earn revenue from it, but it will expedite the time to market. And it will also help customers understand what others are doing in the industry. Same.
All right. All right. So we have some of the other questions as well, but we are running out of time. I will get all these questions answered by Souvik and mail it to the respective attendees with the recording of the session as well. And we will definitely encourage the feedback of the attendees as well. So anything to you want to add, Souvik, as a last note to them?
No, I'd like to really thank you all for taking this time out and listening to um, our point of view, listening to my webinar. This will be hosted on our website, and I'm sure we're going to send the link to all the participants as well as the ones who could not join because of other priority items. But we really appreciate your time. If you think you have interest, you have any business in claims area, purely from information exchange purposes, I'd be happy to get into a call and discuss, or me and my team members would be happy to do that. So with that, I really thank you again. And that's it from me today. Thanks.
Thank you so much, Souvik. And thank you to our audience. You all have been fantastic. Thank you for joining in. You all have a productive day. Thank you so much.